So in the previous video, we talked about least square estimate, right? So it's trying to find the best line to fit all data point, but it doesn't really talk about statistics, right? We don't talk about why this is good, right? In statistical sense, right? Just like given the data, this is the best fit line, okay? So now we are trying to make 4 classical assumption and try to justify this is a good estimator, okay? There's no, before we don't talk about any randomness, probability, or statistics, right? So that is, now we're going to talk about that, okay? So first we talk about is the model is quadratic specified. So actually x and y are related linearly in the following fraction. That is, yi, the y is related to x with the unknown parameter alpha plus beta, and also with another term called the error, which is epsilon I. So this is a random term or error term, okay? And this term can be different for different observation, okay? That's why even the same x, we have different y, so that why we need a error term here. And here the classical thing is x are controlled, okay? It's not random. It's like in the lab, people set different x, okay? So because start from statistics, so x are somewhat controlled. In the experimental fraction, the policy changes, or in the laboratory, we decide what x is. Okay. And now we want to talk about epsilon, the error. So this epsilon is going to have a mean 0, okay, 0 mean, and same variance across different observation. So that in simple means the expectation of epsilon I will be 0, and the variance are the same sigma square, okay, for all observation, okay. Common variance, technical term this homoscedasticity, okay. And next one, errors are not correlated, which means that each you observe one observation has positive error doesn't mean the next one will be negative or positive, okay, are not correlated, okay. This is sometimes violated for time series observation, right? Like stock market, right? If the market tend to doing well, usually continue to do well, okay. And that is there's a, you observe one observation, will tell you something about the next observation, okay. So but in here we just talk about each observation more like independently generated, is not related, okay. Knowing one thing doesn't know the other, okay. If you accept this 4 assumption, okay, underlying how x and y are generated, okay, then okay, it will be what we call the least square estimator we derived in the previous video is an unbiased estimator, okay, and they have the lowest variance among the class of estimators that they are linear index, okay. What it means is what we have, the estimator and least square are the unbiased, which is good because we need unbiased estimator, okay, which we learned in estimation chapter is a good thing, right? If we repeat this many times, right, it actually we can estimate the alpha and beta. And second is very efficient, means it's most accurate, the lower variance among the class of estimators, although linear index. So we consider another estimator also linear index is one of the best, okay. So what should be the interpretation of the model, okay? And the estimated model, what we have is y hat equal to alpha hat plus beta hat x, right? And alpha hat would be saying that, oh, what on average y would be if x is 0. So if x is 0, then y hat is equal to alpha hat, okay? So it's only meaningful if x has some value around 0. If x is way above 0, this alpha doesn't mean a lot of things, because the interpolation from very large number to x is not have anything to say, because you collect data, the data is around certain value. If the value doesn't include 0 or not near 0, then S0 doesn't mean a lot, okay. You can say something, but it doesn't have a lot of meaning. And the beta head will be saying that how much y will change on average x increased by 1. Okay, but again there's no causality but just correlation. Okay, and the idea of regression is trying to say how the variation of x, okay, above its mean, right, and how y will respond. Okay, so that's why if you change the data x and y by minus own mean, okay, you regress instead of y over x, but you regress y minus y bar and x minus x bar. Okay, we get the same idea. Okay, in that case the alpha head will be 0 and the beta head will be the same thing. Okay, so that's interpretation of this regression. Okay, so that's the end of this part. Thank you.